Okay, now that you've had a fair amount of time to work, now let's see what we think the answer is. What do you think? Start with Davis and then Brian. What do you think, Davis?
AB is approximately 34.1151.
Okay.
And BC is approximately 39.249.
Okay. Now I want you to look at your answers and tell me whether or not they actually make sense based on the original picture. We'll come back to you. Brian?
So say AB equals 36.6 and BC equals 26.1.
So you're still sticking with those answers? Okay. Any other proposals?
AB is 34.1 and BC is 39.
Okay. So before I reveal answers, there is a theorem that has to do with the size of this angle and the length of the side, and the size of this angle and the length of this side. Anyone remember the idea? I don't care about the name, but anyone remember the idea? You should. What's the idea? If this angle is bigger than this angle, then what can you say about these two sides? Go ahead, Chris. Absolutely. You remember the name of that theorem? Yeah, the Hinch theorem says that if you've got one angle is bigger than another, then the side opposite would be longer than the side opposite the smaller angle. So now, Davis, does your answer make sense? Why? You weren't the only one who proposed it. It was proposed by others. So why doesn't the answer make sense? Okay, because BC must be smaller than AB, and you proposed that it was bigger. Okay? So you have to think about what makes sense and use all the tools available to you. Okay? So the big reveal, the answer is, I'd rather not say. So I am going to leave it open for bonus points. So as I did last time, there are 5 spots available for bonus points. 5 spots available. If you would like to propose an answer to see if it's right, you can try as many times as you want until those slots are filled. So there's still slots available for 7.6's warm-up. Write your name and your answers on a small little scrap piece of paper. Give it to me when there's a lull in the activity, not while I'm standing here working with you or leading the class. And I'll tell you whether it's right or wrong, and if it's right, you go on the list. If it's wrong, you take another shot. Any questions or concerns? No? Yep, you can work with another person, absolutely. Okay? So I know that it's not as gratifying as finding out if your answer was right or not, but I want to give some people some more time. And I also want to see who's willing to go a little bit further and who is willing to persevere through the process to actually get it right. And we will revisit this question next time I see you. Okay. So we've done a good job getting our brains in the right frame of mind for today's lesson. Today's lesson is a culmination of the entire chapter, and so what we're going to do is quite literally take everything you've learned and wrap it all together, kind of like you had to do during today's warm-up. And kind of the way I've been kind of preaching to you over the past few weeks is that we're building a toolbox, and now we're going to need to learn how to access that toolbox and all the different tools available to it. We are going to add one new tool. It's actually a set of tools, but you already know it, and it's calculator-based, so it's not a huge leap from what you know. So, our objective today is to use trigonometric ratios to solve some real-world problems. And we're going to build through the process today. Does anyone have any comments or questions so far? All right, so one of your goals today is to leave here knowing how to do something called solve a right triangle. So that's a strange phrase because a right triangle is a physical object, and how do you solve it? So I want to explain first what it means. It means that you find all the missing details for that right triangle. So if I ask you to solve a right triangle, you need to find me all the angles and all the sides. To do this, you have to have a minimum of information. You have to have at least two sides, or a side and one of the acute angles. You already know one of the other angles because it's a right triangle, so one of the angles is going to be right. Based on having those pieces of information, or maybe even more, you can solve for every other detail. And we do that by using the tools that we have available to us. Any questions about that? So for example, let's fast forward to your test in 2 or 3 days. There's going to be a set of questions that says, solve the right triangle. And you're going to have to know instantly what that means to do. Okay? Any questions? So here's the new tool, or set of tools. It's called the inverse trigonometric function. So there's sine, there's inverse sine. There's cosine, there's inverse cosine, and there's tangent, and there's inverse tangent. And you'll see that it's actually the inverse of the button on your calculator, or you basically access it using the second function on your calculator. And so here's the deal, and this is where it becomes really powerful, is we've learned over the last couple of lessons how to find a ratio. You can find what the sine of an angle is supposed to be. Now we can use that to find out what the angle measurement is. So inverse, we're kind of going backwards. Okay? This is where it becomes very powerful. So this is written out as a conditional statement, so I want to make sure we're clear on what's going on here. If the sine of A is a particular ratio, or if we write it as a decimal, if we take that value, put it in this statement, the inverse sine of that same value will tell us what the angle was. So in this case, we don't know the angle, but we know what the ratio is. Now if we take that ratio and do the inverse sine, we will get the measure of the angle. Any questions about that? It'll make a lot more sense when we put it into practice. And so this works for cosine and tangent as well. Good. So let's jump in and start using this. All diagrams can be sketched. You do not need your ruler to draw a perfect picture right now. And you do not have to copy the text of a question unless it's absolutely necessary. All right, so today we're starting out very simple. I would like to know, with your help, the measure of this angle. So our perspective is we're standing right here. I would like to know the measure of this angle. We would like to use our toolbox of trig functions, which means that I would like us to use this piece of information and this piece of information. So taking all those details together, which trig function can we use to represent a statement that starts with this angle and uses this piece of information and this piece of information? Which trig function can we use? We got 1, 2, 3, 4, 5 ideas, 6 ideas. Kayla, which one? What were you going to say? Say what? Tangent. Tangent uses opposite over adjacent, right? So The 15 is opposite, the 20 is adjacent. So we can write this statement. Tangent of A, we don't know A. The tangent of A is going to be the opposite over the adjacent. But we don't need to write O and A because we know them. So opposite is 15 and adjacent is 20. We're extremely high-level math students, so we can quickly do mental math and convert 15 over 20 into a more usable number in this case. So 15 over 20 is the same thing as what? Alyssa? Right. And as a decimal? 0.75. So the tangent of A is going to be 0.75. Any questions on how we did that? This is going back 2 lessons. Should not be a big deal for you. Here's where we use our new tool. Now we take the 2 details and flip-flop them. So this is going to go over there, and this is going to go over here, and we're going to add in a little negative exponent, -1 exponent. So now we can write the statement that we really need. We need the inverse tangent of 0.75 will tell us the measure of angle A. Does anyone have any questions about that? So I apologize, I got an app that will actually show your calculator, and I had meant to have it up and ready, so give me a moment. Hopefully it won't take very long. So, you can, while we're waiting, you can see the calculator here. So you're looking at, same thing I'm looking at. So the inverse tangent is, you see the yellow writing right above the tangent button. To access that, what's yours? Is yours green or yellow? Green? Okay, it's a little hard for me to tell. So to access that, we need to use the second button. So go ahead and click the second button, and then click the tangent button, and you should get this on your screen. And now we type in the value that we're going to find the inverse tangent of, and what was the value we were going to use? 0.75, so 0.75, close the parentheses, and go ahead and hit the enter button. You already did it? I'm going too slow. So what is the angle to the best of your understanding? Davis?
36.9.
About 36.9 degrees. So the measure of angle A is approximately 36.9 degrees. Anyone have any questions on how we were able to use the inverse function? Good. Here, go.
I'm just sort of asking, will we ever get an exact answer, like not an approximate, if we ever use the inverse?
What do you think?
Sure.
Okay. Well, let's go through today's lesson, see what happens. And then you tell me later on what you think the answer is, okay? Alicia?
I was going to ask, because I thought it would end up being 37 instead of rounding it.
Well, it says to the nearest tenth of degree. But had that not been there, I would have accepted 37 degrees or 36.86 or whatever it was in the calculator, rounded to an appropriate number of decimal places. Okay? Good. Any questions on how we did this? So in this case, we had a diagram. We pulled some details from the diagram, wrote a statement, and then basically rewrote it in a way that would get us the piece of information we needed. Any questions about that? So now, I'm actually going to go maybe a little bit simpler. Now there is no diagram. Angle R and angle S are going to be acute angles in a right triangle. I'm not showing you what it is. We're going to use a calculator to approximate angle R and angle S to the nearest tenth of a degree. So I've given you two statements. The sine of angle R is this value. Cosine of angle S is this value. Find the two angles. So let's start with B. So if you look here, this statement that we constructed from the diagram, that statement's already done. So we just now need to write the inverse statement that we can use with our calculator. And so now we're already ready to flip-flop these two pieces of information and change it to the inverse sign. So write it out. The inverse sign of 0.87 is going to equal the measure of angle R. Use your calculator. You already got it? Round it to the nearest tenth. So what do we get, Dalton?
6.5.
Yeah, what? 6.
60.5.
60.5. Very good. So the measure of angle R is approximately 60.5 degrees. Any questions about that? You already got angle S?
Yeah.
What does angle S come out to? I have no idea. What does it come out to, Zabari? What did you get? Approximately 81.4 degrees. So the measure of angle S is approximately 81.4 degrees.
On the test, if we don't put the approximate sign, so if we have someone with an equal sign, is that going to be wrong?
I'm sure I can deal with it, but there will be a time when a teacher will not. Okay? Brandon?
We're going to get these in the test.
Say it again.
We're going to get these during the test.
Those or something similar. Okay? Any other questions? All right, so let's see how you do on your own. Remember, I ask you to stretch your mind. So don't assume that I'm just going to give you a carbon copy or a copy of the same question, a clone copy of the same question with just different numbers. So make sure you read, make sure you answer the question. You got 2 parts, you got 3 minutes. Feel free to discuss with your teammates. Feel free to ask questions of me. There's time left and you're done. Compare your answers with your teammates, your new teammates. See how you did, see how your answers compare.
How do you get
Six? Yeah. Six.
Oh, I just did angle.
60.
It's probably not.
70. That's what it's doing.
All right, so let's see how we did so far, how we're doing so far with using inverse functions. So look at the label on your desk so you know your new number. And we're on part A only. Which angle is angle A? I've got student number 2, 1, and 9. Student number 2, what do you say?
Angle 1.
Student number 1.
Angle 1.
Student number 9. So you all agree that angle 1 had to be angle A, and it is angle 1. And part B, what's the measure of that angle? I've got student 19, 6, and 12. Student number 19, what do you say? Hmm? Who's student number 19? Oh. Okay. Student number 6? Okay. Student number 12? Okay. So we get approximately 61.9 degrees. So I intentionally tried to trip you up a little bit, although it wasn't incredibly ridiculous. So how did you figure out which angle had to be A? What logic did you use to figure that out? We'll start with Ania, and then we'll go to Zabari.
Like, if the bottom is longer than that leg, it has to be smaller.
Okay, but what does that have to do with knowing which one is called A? You figured out which one has to be bigger. Are you saying that you did part B first and then you did part A?
What? Yeah.
You did part B first and then you did part A? Okay, that's fine. Zabari?
I found the ratio of the since it says tangent, I ratio, so I did 27.5 more, and I got.
Yeah, if you just look, and I'll be honest with you, this you can do mentally. Angles 1, you can figure out tangent is this over this. Angle 2 tangent is going to be this over this. You already know which one it has to be. Can someone say why? If tangent of angle 1 is this number over this number, and tangent of angle 2 is this number over that one, why do we already know which one is the right one? Jada? Okay, very good. Brandon, what were you going to say? Yeah, you have to get a number greater than 1. It's 1.875. 14.4 over 27 is not going to be over 1. 27 over 14.4 is. So that had to be the right combination. So angle 1 had to be angle A.
Would it be okay to do what I did on the test?
Of course. I mean, if it's a computer-based test and it gives you only part A and you can't see part B, then you're kind of stuck. But if you can see both, of course, you can work it any way you want. Dalton and then back to Brandon. Okay. So using intuition. Okay, Brandon?
I got two questions. Could you put 62 about
That's fine. That's fine.
And then I found number 8. I mean,
Okay.
letter A, because I thought it as a 60, 30 line triangle, and I figured out one.
Okay.
Whatever.
Okay. All right, good. Any other comments, questions? Okay. So to remember, what I had introduced earlier is that if I ask you to solve a right triangle, that means you have to find all of the missing pieces of information. Any questions about that? Good. So that's what we've been building to. So here we go. Solve the right triangle. So let's not worry about this yet. So, solve a right triangle, find all the missing pieces of information. And so when you take a test in 2 or 3 days, it's either going to be correct or incorrect. You either get all the pieces of information or you don't. So let's set ourselves up for success, and let's list the pieces of information that we need to find. So could someone give me one thing that's missing that we need to find? Chris? Okay, so we need to find QR. So when we're done, we need that. What else do we need? Alyssa? We need PQ. And what else do we need? Michaela?
The measure of angle RPQ.
RPQ, and since there's only one angle there, we could just call it angle P, measure of angle P. So we need those 3 pieces of information to do the job of solving the right triangle. Okay? Dalton? I don't know. So I'm asking for these pieces of information. How to get them is up to us, using any tool in our toolbox. So Dalton has already proposed using a tool. What tool are you proposing? Okay, so are you certain that this meets the criteria? Okay, so this is a 45, 45, 90 degree triangle, which tells us that there's a relationship between this, this, and this. So what do we already know? We know a few things already. Alicia?
Well, if 2 sides are x, then the 12 will be x radical 2.
Very good. So the 12 is equal to x radical 2, and that will help us find the x. What else do we know before we even do that? What else do we know? Measure of angle P is 45. So we're already done with one of the details. So we're already filling stuff in. Okay, what else, Jada?
Sides PQ and QR.
Very good. I'm really glad you picked up on that. So we can actually just find this, and then we automatically find that, because what type of triangle is this? What type of triangle is it? It just should be a moment where you're frantically waving your hand going, I know, Mr. Gallagher. Thank you for playing along, Davis. What type of triangle is it?
It's 45, 90.
Right, it's a 45, 45, 90, but what type of triangle is it? You can
Triangle, isosceles.
isosceles triangle, very good. Because we were talking about congruent sides, and so that tells us it's isosceles. So we could just find one of them, and we automatically have the other. Okay? And so Alicia already gave us the path to it. 12 is going to equal x radical 2. Solve that. What do we get? You already got it, Alicia? Okay, don't say it yet. Give people a chance to, because you have to know how to do that. Give me a thumbs up when you've got it. Yes.
No, I was gonna ask, can you just use sign?
You could. Absolutely. Actually, I would love you to do that, see if we get the same answer. Give me a thumbs up when you've got it, one way or another. Got 1, 2, 3, 4, 5, 6, 7. All right, Alicia, what does it come out to? 6 radical 2. So the distance from Q to R is 6 radical 2. And as Jada pointed out, they are congruent, so that's 6 radical 2. So we solved the right triangle. Any questions on how we did that? Any concerns? All right, so let's continue to build on that. And let's do part B. And this time, we're going to do it in quick little bites. So what I'm going to ask you to do after you sketch the diagram is I want you to individually identify what's missing. Then we're going to come back as a group, and then we're going to devise a plan for finding the pieces of information. So you first write down what is missing. You did. Okay, good. Okay, so what is missing? Give me one thing that's missing, Sebastian. Measure of angle P is missing. Give me something else that's missing. Tristan? Measure of angle N is missing. And what else is missing? Ania? PN is missing. Good. Now I would like a logical path to finding each piece of information. Can someone pick one of these three and tell me how we're going to do it? And keep in mind there's more than one way to do it. Okay, we'll start here, then here. Go ahead, Sebastian. Pick one of these missing bits.
To find PN, you can do the Pythagorean theorem.
To find which? Okay, so to find this, we can do Pythagorean theorem. Anyone have a different way to get Pn? Okay, see if you can gather your thoughts. You might be right. So let's go ahead and do the Pythagorean theorem to find Pn. Okay, so this must be A, that's B. Wow, it doesn't get much easier than this. Got it already? Nice having a scientific calculator.
Do you want to be decimal form?
I don't know. What does it come out to? I have no idea. What does it come out to, Alyssa? 13.9. What is it? Is it in something radical form that is reasonable?
No.
Sebastian, you started us off. What did you get? Radical 193. So that's not divisible. Not divisible by much at all, if anything. Okay, so radical 193 will be great. And you said it was what, Alyssa? 13.9 approximately. So let's go with that. Approximately 13.9. I guess I could change the symbol to an approximately equal to symbol, but it's okay. Or you could put radical 193. I'm fine with it. All right, so we got one of our pieces of information. Can someone pick one of the other ones and tell us the pathway to do it? Dalton was next, and then we'll go over to Brandon.
You can find angles by using cosine.
Okay, well, pick one. So to find angle N, you want to use cosine. Okay, so cosine of angle N. Cosine of angle N. So could someone remind us, cosine uses which two pieces of information for cosine? Zabari? What was it? Adjacent? Adjacent over hypotenuse. Okay. Well, now we have the hypotenuse here, so we can use adjacent, which is 12, over hypotenuse, which is 13.9. And now how can we find n from that? We can find the ratio, but how do we find n from that? Crickets? We find it using crickets. Go ahead, Zabari, you're on a roll.
You would have to do the inverse of the cosine.
Okay, so we need to use the inverse trig function, the inverse cosine. So we have to flip-flop this, and here's what's really cool about your calculator, is you can put it in your calculator just like this. You don't even have to do anything. So the new statement becomes the inverse cosine of 12 over 13.9 is going to give us the measure of angle n. So if you go to your calculator and clear it out, if you type in inverse cosine and you put 12 divided by 13.9, close the parentheses, it will do the division and then find the inverse cosine for you. Any questions about that? Is that what you got? 30.3 approximately. So we get the measure of angle n is approximately 30.3 degrees. Any concerns about that? So how do we find the last piece of information? Brandon?
I found M, the measure of angle P by tangent.
Okay, you use tangent. Nice. Maria, what were you going to say? Tangent. Good. And what did you get?
I got for P, right, 59.5.
59.5. Anyone have a different way of doing it? Daniela? Yeah. Triangle sum theorem, of course. Now we know angle n is 30.3. We already know that's 90, so to find this is just a matter of adding and subtracting from 180. There's actually another one that we could use.
I use cosine.
Use cosine. So cosine of p, you used adjacent over hypotenuse, and you found the same answer. So what did it come out to? 59.8 approximately. Any concerns or questions? What did it come out to? Well, the other ones were rounded also, so okay. Awesome joke. Okay, any other concerns, questions, issues? All right, so let's see how you do on your own with this. And remember, I keep saying similar statements over and over again. I'm asking you to stretch. So it's not going to be a clone question. So you got 4 minutes on the clock. Of course, you do not have to copy the question. It's a checkpoint. But find me what I am asking for. If I need to stretch the time a little bit more, I will. Actually, we're a little short on time, so I'm going to have to drop the time by about a minute. apologize. My intention was not to give you that limited amount of time, but hopefully we were able to get somewhere. So I'm not going to use the equity bars. I'll just ask for volunteers because I know that you may not have finished. So we'll start with Chris Dalton. Go ahead, Chris. Okay. Okay. So does the ramp meet the standards? Okay, Dalton, what did you think?
The horizontal distance is 191.4 and ramp angles are 4.5 degrees. And
Okay. And yes, it does meet the standards. So you said 4.5 degrees. It's a little bit further off than 4.2. So I'm not sure how that happened. So this was really a combination of everything I've been asking you to do. We're given a diagram of a generic ramp, but then we're given specific pieces of information here and asked to kind of analyze it. So this was given to us, and then this was given to us, and this is not given to us. So we've got, this is 16 feet, and this is 14 inches, and this is missing. If you did not catch the whole feet to inches thing, then you probably got totally messed up. So that's a reading issue, that one piece of information was given in inches and one was in feet. So before you did anything, that 16-foot ramp should have been converted to inches, or you convert the inches into feet, which would be 1.16 repeating feet. Yes?
I realized why I got the answer. It's because I rounded 191.5 to 191.4.
Oh, okay, so your answer here was a little bit different. Okay, so I can deal with that. Anyone have any comments or questions, keeping in mind that I have limited time? Go ahead.
I accidentally switched 16 feet to X, but it's still
Yeah, I'm going to have to look at how that happened. Not sure. Brandon? Okay. Yeah, there's quite a few people who did. Sebastian? Ah, okay. Okay, thank you. Good. All right, got a little lucky. All right, so we did have a little ways to go, but that's okay. We've done a good job. Your homework is on page 480. You're doing 6 through 28, 34, and then 38 A, B, and C. You can start exploring the interactive test or the interactive quizzes that are available for each section, because your test is going to be on Thursday.